Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-BUENA Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we are at Seibert Elementary, home of the Raiders, and we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Gustavo.
And in studio with us, we have Caleb, a 7th grade student. And Caleb, if somebody wanted to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemath.net. And on social media, we're on Facebook, Instagram, Twitter, and YouTube.
All right, so there's a lot of ways to get a hold of Do the Math. And we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year until 5:30 in the afternoon. Just a little side note, because we did have a student email a problem to us yesterday, and we'll be able to address that later on and email that back. But if you ever do need to email a problem to us here at Do the Math, please do so on a Monday, Tuesday, Wednesday so that we can see them on Tuesday, Wednesday, address them, and then email back an answer. If you send it to us on Thursday, Friday, it's a little bit more difficult to go ahead and address that, but we will certainly try our best to do so. So, Caleb, you are in 7th grade. Where do you go to school?
I go to school at Grumman Academy in Arvin.
And how long have you been there? Is this your first year? Have you been going there for a while? Or?
This is my 5th year.
Your 5th year. So you've been there and you're pretty comfortable with it.
Yes, I am.
Do you like the extended vacations you get every once in a while?
I do.
I was going to say, because you guys had an extra week off that last week, and today, well, this week was your first week back to school.
Yes.
So what is the best thing about 7th grade?
I really like the shorter periods and just moving around a lot, and especially that I get to have different classmates in every class.
Okay, yeah, so that is a big thing when you get into 7th grade, is moving around, different teachers, different classmates. You're in there for like 45, 50 minutes or something like that, and then boom, off to the next one, right?
Yes.
All right. Well, what we're going to do is we're going to have you head over to the board right now. We're going to have you work on a easy problem to kind of get started with today, all right? So head on over to the board. Gustavo, if you would please go ahead and you can write this equation up on the board, and then we'll have Caleb solve it. 3x plus 4 equals 13. So Caleb, if you would solve that and just kind of explain it as you go through it.
Okay. First, what I would do is I would isolate this variable. So I want to get rid of this. So first I would add -4 to this, so that way this gets 0. Then I do the same to the answer. So -4, you would get 9. Then what you would want to do is write out your equation. So you have 3x equals 9. So now what you want to do is a mixed operation. Since we have these two, you want to divide this by this. So 9 divided by 3 equals 3. So x equals 3.
Very good.
Nicely done. So how would you check? Because it's a pretty easy problem, but there is a way to check it to make sure that it's done correctly. And if you need help with that, Gustavo's right there.
The way to check this problem is whenever two numbers are by each other, you would multiply them. So 3 times 3 is 9, and 9 plus 4 equals 13.
Okay, perfect. And how did you use this 3 in here for the people at home?
This 3 right here?
Yes.
Well, you would multiply this by this to add that.
Okay, so what you're saying is that you inserted or replaced it.
Yes.
Right? So you had 3 times 3, and then plus 4 equals 13, correct?
Yes.
Excellent, excellent, very good.
There you go. Nicely done, guys.
Thank you.
There you go. As a reminder, we do have phone tutors available until 5:30 this afternoon. Time now for today's Math in the News. All right, today's Math in the News has to do with college athletes, NCAA athletes. And last night was the playing of the college football championship where LSU and Clemson went at it, and LSU came out victorious in that one. And basketball is going on right now, kind of at the beginning of the basketball season for college. And you, I found out, are an athlete also. So what sports do you participate in?
I participate in baseball and basketball.
Baseball and basketball. So obviously you must have basketball going on right now.
Yes.
All right. And have you heard about athletes in college possibly getting paid?
Yes, I have.
You have. What do you think about that? Because for over a century, right, athletes did not get paid. They got paid to go to school, right? They got a scholarship to go to school, but that was all they received. So what do you think about that?
I think that's tremendous that I can do something I love and get paid for doing it.
And you know what? There are a lot of students like that. So let's take a look at a graphic that was in the newspaper the other day. And this one was a survey about athletes in college and whether or not they should get paid. So do you think the NCAA should or should not allow college athletes to earn money from endorsements or sponsorships? So 66% said they should allow it. So there were a little over 1,000 people, 1,000 adults that took this survey, and 2/3 of them say the athletes should be compensated for whatever they're doing. All right. So take a look at some of the other numbers we have here. Do you think colleges and universities with major athletic programs should or should not provide athletes participating in those programs with? So a lot of them say they should provide them with a share of the revenue from broadcast rights. So if they're on TV and the school's making a lot of money, they're saying, yeah, the athletes should get some of that. Now that's 52%, but it's a little bit more than 50. Additional spending money. Now that's going down. So they're saying, all right, you're getting a scholarship, you're going to school, which could cost, between $40,000 and $100,000 or even more based on where you go to school. So they're saying, well, you don't really need additional spending money, you've got some. A salary, that goes way down. 60% say, no, you're not getting a salary because you are in school. And the key, I think, with that is when people answer that, you are a student athlete, where the word student comes first. You are at a university, a college, that's what you're doing. And then our final one, exemptions from academic courses. So that means you don't have to take this course because you're an athlete. What do you think of that one?
Well, I mean, to be an athlete, say you went professional, to become professional, you don't really need an education in college, but I still definitely think if your career goes downhill from there, you should get educated. Man,
you never know what's going to happen, right? I mean, yes. Injuries could happen and things like that, so you've always got to be ready. So those are just some of the numbers and what people think about NCAA athletes being compensated and additional spending money and not having to do all the courses. But that was merely a little over 1,000 adults, and that is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. Right now, we do have an opportunity. We're going to go out and about and see what the kids at Seibert Elementary are up to.
We are at Seibert Elementary, home of the Seibert Raiders. I am JJ with Marylou.
And hello, welcome. So again, as my friend JJ has said, we are at Seibert Elementary today, and we are with the ACES After School 4th grade class, who is awesome, and we are ready to do some math. Now, JJ and I have already been talking, yes, and JJ has been talking about decomposing fractions. So, JJ, can you kind of explain again what you started doing?
I started getting a fraction and then cutting one of them into smaller parts.
Okay, so you first broke it into thirds, right?
Yes.
And then you said that this whole entire part equaled 1. Yes?
1 whole.
1 whole. So then you started off with 1/3. Then you broke that 1/3 in half, and you said now you have 2/4. right? And your 2/4 came from 1, 2, 3, 4. Then you said, I'm going to do another line, and now I have 3/5. 1, 2, 3, 4, 5. Yes? So then we took this information, and we said, okay, do these 3 fractions really equal each other? Does 1/3 equal 3/5 and equals 2/4? So we did another picture, right? So we broke this up. Here's our 1/3. Here is our 3/5, and here is our 2/4. Do they equal each other? No. We need to have this decomposed work. How can we make this work? I'm already seeing people out there drawing it on your board. We need to make this work. How can we do this? I want you working with your partners, okay? You have whiteboards. Start thinking this through. We know that these 3 numbers don't equal each other, but what can we do to decompose this to make this into smaller parts? How can we make it work, okay? JJ, go back over there and go with your group and let's see, okay? Let's see how this can work. So talk with your partners. How can we break this into equal parts? Okay, I see that you have something going on over here. What is your thinking?
But first he put the 3 in, so I want to break it in half because he's putting more in. If he usually did that, it was supposed to be 5 under 3. So he's supposed to put that, but he was starting with this first. But if he's trying to break it in half, he will have to erase this.
So
start a new one.
are you talking about breaking this in half? If he breaks this one in half, what does he have to do to the other 2?
He had to start a new one.
If you break this one in half, do you also have to break those in half as well?
No.
You don't? You are doing that, right?
Yeah.
You broke this in half, you broke this in half, you broke this in half.
We did this in school.
Okay, so this 1/3, this whole big 1/3, has now become how many pieces? You had 3 boxes, but now you have how many boxes?
6.
6. So what does this 1/3 now become?
That becomes 2 6.
Okay.
And then, so when we were in school, we would do it like this, and then if we shaded like 1/3 of the box, and then we cut it in half, so it would be 1 6 plus 1 6, which equals 2 6.
Okay.
But-
Now, what if you cut these 2 now in half?
You couldn't cut the, or you could, but you would have to do it to the other 2 boxes.
Okay, let me get another color. Here. Oh, keep on working on that. Okay? I want to see what you're doing over here because this is really interesting. Explain what you're doing here.
I just started like with 3, and then I shaded one of them.
But instead of breaking it vertically, you broke it horizontally.
Because this is like, if we're folding it, then that's like how much. So earlier, right now, I had nothing. I didn't have this line. I had these, so I had 3, and I had these left. So I counted all of them and I put it as the whole. And then
So now you have how many total boxes? Because I see you have your 4. 4 out of what now?
12.
So your denominator is what?
12.
Okay, so you started off with 1/3, but then you broke it horizontal to have 9ths, right? And so you had 3 9ths. And then you broke it even more to have 4 12ths. All right, you're gonna even break it more? Can you? Is there a way to break it in more? So we're finding lots of different ways. Now, what's our thinking over here?
We're gonna do like, cause you know how we have 3, and then we parted it to make it into boxes to make it 4, and so we did this, and then we got 1/3, and then cause at first we'll have 2/4 next, because at first right here we had 1 line, and then we had and then if we had one line, we would have two
Okay,
fourths.
and then I really like what you did here because you broke it in half. So now how many total boxes do you have? You have 1, 2, 3, 4, 5, 6. So how many 1/3s do you have there? You have 2 out of a total of 6, right? So you have 2 6. So you could say 1/3 equals 1, 2, 2, 6. Wow, so many different ways to decompose a fraction. Well, we have more fractions to come, but we're going to send it back to the studio for right now.
All right, thanks for that, Marylou, and thank you to the students out at Seibert Elementary, home of the Raiders. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, and right now we're going to go to the phones. And Caitlin, how are you today?
Good, how are you?
I'm excellent myself, and you're in 7th grade, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Negative 258 is less than or equal to 6, open parentheses, negative 6k plus 5, close parentheses.
Perfect. Well,
All
thank
right.
you.
So you can give me that paper there, Gustavo, if you don't want to hold on to that.
Sure.
All right.
Well, Caitlin, thank you for calling in today. And let's see. So would you like to start on the left side or on the right side?
On the right side?
Perfect. And so we want to start with 6, correct?
Yes.
All right. So what do you think our first step should be?
To distribute the 6,
And so we're going to distribute that right in here, correct?
yes.
Perfect. And then 6 times negative 6 gives us a
Negative 36k,
perfect. And then secondly, we're going to distribute that 6 to the 5. And 6 times 5 is
30.
perfect. Great. Are we done with this side for now? Yes. Perfect. So now I'm just going to go ahead and rewrite this. 2 5 8. And what do you think our next step should be?
To get rid of the 30.
Yes, this 30. So we want to move it over to perhaps this side, correct?
Yes.
And how are we going to do that?
We're going to do the inverse operation and subtract 30
Perfect.
from both sides.
Yes, and that is correct. We want to do it from both sides. Great. And so that will cancel this out, correct?
Yes.
Great. And then what are we going to get over on this side?
Negative 288.
Okay, negative 288. And that is correct. Sometimes this could be a challenging side for many people when adding 2 negatives, but you did it perfectly. And so over on this side, we are going to bring the negative 36k down, correct?
Yes.
Perfect. So what should be our next step here?
To do the inverse operation again and divide negative 36 from both sides.
Perfect. Yeah, so by dividing negative 36, and I'm just going to put this over a fraction. A fraction here means division. And we'll do that over on this side. And so this will cancel our 36, correct?
Yes.
And then that will leave us with the k all by itself. Do you remember the rule of when we switch this sign?
When you are dividing or multiplying by negative number, you're going to switch the inequality sign.
Correct. So would that apply at this moment?
Yes.
Okay, so now we're switching it over to this side, correct? And
Yes.
And then what about the negative 288 divided by negative 36?
It equals positive 8.
8?
Yes.
Okay.
And 8 is correct.
And is that going to be a positive or a negative number?
Positive.
Excellent, yes. So then let's go ahead and circle our answer, or in this case, kind of a rectangle, and that should be our answer.
There you
Good
go.
job.
Nicely done, Caitlin. Thank you for calling in this afternoon. You've got yourself a meal courtesy of our friends at Broken Yoke, so congratulations on that. Hey, we do have phone tutors available until 5:30, and there are probably a lot of people that watch the program pretty regularly going, hey, you know, we see a lot of the tutors and we recognize them, but Gustavo is brand new today.
Yes.
So Gustavo,
I'm excited to be here.
let everybody know kind of like where you're from, kind of what you do on a regular basis.
Absolutely. So I'm a native of Bakersfield, and I'm the director over at KERN Tutoring. So we help a lot of students as well in math and other subjects.
Right. So, I mean, a lot of students know, all right, yeah, I know I can go to do the math, but you have tutors available at different school district sites.
Correct. So we have we can send our staff members to different school sites. We have an office in downtown, and we have great staff members. We have people with math degrees from UCLA, UC Berkeley. So we can we can help students from kinder all the way to college.
All right. And there are some students that are like, well, I kind of got the math, but I need a little bit of help with reading or something else. And you provide services for that as well.
Absolutely. Reading and reading comprehension is one of our more popular subjects for elementary age students.
All right. Well, you know what? We've got a middle school student in here right now, Caleb,
Yes.
a 7th grade student. And it's time for you to get back to work, young man. You ready?
Yes.
All right. Over to the board. Here we go. We're going to have you working on a couple of equations. So, Gustavo, if you would be so kind as to write these up
Sure.
there. 6x plus 9y is equal to negative 24. Underneath that, our next equation is 3y equals 6. So Caleb, I know you haven't done specific problems like this, but looking at it, kind of talk about how you would want to start this and if there's a way to make it easier to go with it.
Yes. So first I want to do, I'm going to look at this second equation right here, and I'm going to want to solve for what this is. So I already know that 3 times 2, let's substitute this y for 2, y equals 2. 3 times 2 equals 6, making this equation true. So then I would want to apply what we know here up here. So now we're going to want to do 9 times y. So we're going to write it out, plus 9 in parentheses 2 equals 24. Then what I'm going to
So one thing that we want to be careful with is just making sure that we include that negative on there, right? And then 2, I like that you wrote the whole equation out, because sometimes I've seen students that only plug it in there, but they forget another number. So writing the whole equation is a great strategy.
Then I'm going to want to simplify this, because this can be simplified. So this 9 times 2 equals 18. Then I'm going to want to write the equation out again. 6x plus 18 equals negative 24. Next, what I'm going to want to do is I'm going to want to subtract, or I'm going to want to get rid of this 18. So I'm going to subtract 18 to get 0. Then I'm going to want to do the same thing here. So subtracting 2 negatives is going to get you a positive.
Well, you can double check on that step right there. So what would our answer be on there? What do you think our answer would be? So 24 and 18,
We're going to want to add these two to get 1, 2, 42.
Perfect. Now, because we're adding, correct?
Yes.
So are we going to have a positive or negative?
This will be positive.
Okay, so very close. So we have rules for multiplication and adding and subtracting, right? So when we multiply a negative times a negative, we change it to a positive. However, when we are just adding the numbers, we are actually going to keep this as a negative. Yeah, so you're good. And so, yeah, let's continue. So now we have 6x equals negative 42, correct?
So just using background knowledge, knowing that 6 times 7 equals 42. But in this case, our answer is not 42, it's negative 42. So we're going to have to make this x negative 7, because 6 times 7 equals 42. And whenever adding or multiplying a negative by a positive, the negative takes over.
Perfect. So for the viewers at home, let's go ahead and write. So this was this was the first step, our second step, and then our third step here would be 6x equals negative 42, correct?
Yes.
And then from here, how do we get rid of that x there, which is what you had just explained?
We get rid of the x by,
Or the 6 rather, yeah.
or we get rid of the 6 first by doing well, me personally, this is how I would just do it. I know my multiplication tables, so I would do 6 times what I would think, or rather, for the people at home watching, I would do 42 divided by 6 to get 7. But knowing that this answer is negative, I would put a negative in front of the 7 because we can't just change this 6 into a negative because it's part of our equation.
Perfect. Yeah. So so by dividing that, you would do one of these, correct?
Yes.
Perfect. So there's actually 2 ways of doing it. Like you said, you could do it in your head, or you could do this one. And then we have x equals 42 divided by 6, which you said it was
Negative 7.
negative 7. Perfect. And we can always double check that by if we plug it in here, 6 times negative 7 equals negative 42.
There you go. Nicely done, guys. So you explained it perfectly, right? And you can see how sometimes there's a little bit of a difference when you say something, explain it, and then have to write it out. That way so everybody else can see what you're doing. So nicely done, perfectly done as a matter of fact. For that great work on those equations, you've got yourself a meal courtesy of our friends at Grillin' Burgers. So congratulations on that. Hey, we do have phone tutors available till 5:30. We'll be back with more right after this. Today we're at Branch Elementary, home of the Mustangs, and we're here to Well, we're back again. We've got Priscilla, Cameron, and Caitlin at Branch Elementary working on order of operations. Now is the time when you guys get to come up with a problem. You ready? Because I've given you a couple of problems. They're not very long as far as the number of numbers we have in it and things like that. So what I'd like you to do is I'd like you to come up with one problem. Okay, let's say you put 4 numbers in it all together. All right, so you can add, subtract, multiply, divide. Use exponents if you want. If you use an exponent, only make it to the 2nd or 3rd power though. Okay. All right? So what I'd like you to do is I'd like you to write a problem, make one up. Then I want you to solve that problem. All right? Go. Cameron making a difficult one over there. All right, so let's take a look. So you've got 2 cubed times 9 plus 4 minus 3. All right, so the first thing you did was what?
2 times 2 times 2, which is 8.
Okay.
And then 8 times 9, which I do is right here, so 72.
Okay.
Plus 4 is 76, minus 3 is 73.
Perfect. Don't let them know what the answer is yet. Priscilla, you all through? All right, what did you do?
I did 4 times 6 times 3 cubed.
Cubed.
Yeah. So first I did 3 cubed, which is 27, and then I did 6 times 27, which is 162. Then I did 4 times 162, and do I say the answer?
Please.
I got 648.
So you did 3 cubed first, and then you did all of these. So you kind of worked backwards.
Yes.
Would it work the same if we just went straight across this way?
Yes, because it's multiplication.
Right. Okay, so you can see that by doing that, you were able to do that all in one. It doesn't matter which way you do it, all right? Have you finished yours?
Yes.
All right, what have you got?
I got 7 squared plus 8 multiplied by negative 8 times 2.
Okay, so where did you start?
I started at this, and I got 49 plus 8,
Okay.
which is 57 times negative 8. And then I got negative 456, and then I multiplied that by 2. And a positive plus a negative, or times a negative equals a negative, so I got negative 912.
Good. So I'm glad you guys are all comfortable with the negatives and positives also, because that was an excellent problem to do. So you guys all have the idea on how to do order of operations. You know how to create a problem and solve the problem. So what I'd like you to do is on the back of the paper, okay, what I want you to do is I want you to make a problem, only 3 numbers in it. 3 numbers in the problem. Go. 13 squared, there you go. So once you have 3 numbers, then you're all through. So you're all through?
Just the 3 numbers?
Just 3 numbers. All right, go. So we're going to see if you can solve the other person's problem. Ooh, he gave you a good one, 9 cubed, huh? Well, think about 9 times 9 times 9.
Oh.
Yeah, see, he did you a lovely problem right there. So we know 9 times 9 is 81, right? So 81 times 9. You're all through? All right. And we'll let the students continue working, 6th grade students working on order of operations. We'll see how they do with the final answers next time. And some of the students might be wondering, hey, why was that fighter jet right there at the end of the shot? Well, that's because the elementary school, Branch Elementary, is on the base of Edwards Air Force Base. So we want to thank the staff and students for allowing me to do the math to come out there and work a little bit with the students. We do have phone tutors available until 5:30 this afternoon. We have Caleb in studio as well as Gustavo from KERN Tutoring. And right now we do have another opportunity. We're going to head out to Seibert Elementary.
We are back at Seibert Elementary School with the ACES After School program, and I have a new friend up here. What is your name?
Eva.
And Eva, what grade are you in?
4th.
And what is your favorite thing at Seibert?
My favorite thing is I'm pretty sure it's math
Yay! Why?
because I'm pretty good at it.
Yes. Okay, so we just decomposed fractions, and JJ was like, oh, I forgot that when you break one box up, you have to
Do the rest of them.
the rest of them. Exactly. So you're going to help us today with what?
Like and
Well, with adding and
subtracting.
fractions, right? Because that's the theme of the day, fractions. Okay, give us a fraction. Give us 2 fractions with like denominators. Nice lines. Okay, so we have 1, 2, 3, 4, 5. All right, 5. So underneath, I'm going to draw another one. Or actually, I'm going to have you use that one for the shading. So let's draw another one underneath, okay? And I'm going to draw the same thing. I want you to shade a couple boxes here and shade a different number of boxes on the bottom. Here, go ahead and use the red. Okay, so how many boxes did she shade on the top, everybody?
3.
Okay, so you shaded 3/5, right? And how much did she shade on the bottom?
2/5.
2/5. How do we solve that math problem?
Well, we just add these 2.
Why are we just adding the numerators and not also adding the denominators?
Well, I don't know that question.
Why? What?
The whole never changes.
Very good. Our whole is what? How many is it out of, everybody?
5.
It's out of 5. So what would our answer be then?
5 out of 5.
Okay, show us that. So 5 out of 5 also equals what, everybody?
1 whole.
1 whole. So if this was a candy bar, which is my favorite thing, and I ate all 5 pieces, I ate how much of the candy bar?
The whole thing.
1 whole. So make that equal 1 for me. Oh, you could write there. Yeah, just put equals 1. So can we also make this a subtraction problem?
Yes.
Quick, I want to know the answer. Put it on your board. Okay? What is our answer? If I made this a subtraction problem, write the problem out. Give me the answer. It's 3/5. Minus 2/5. Let's see. And you're gonna help me tell them if they're right or wrong, okay? All right, we about ready? I'm looking around. Okay, 5, 4, 3, 2, 1. Hold up your boards. Let's see. Do they have the answers? Yes. And our answers, if you have what this gentleman has, 1/5, we are correct. Okay, you ready to do another one? Okay. So you guys ready? Yes? But this one, erase your boards. So this one, you can solve it how you want. You could draw a picture. You can solve it however you want to solve it, solve this. And you get to solve it as well up here. You ready? Are you doing mixed numbers as well?
Yeah. No. Yeah.
Okay, I'm going to challenge you.
Yeah. No, we're not.
Okay.
Yes, we are.
Yeah, we are.
Yes, we are.
No.
Because she's not in our class.
Okay, ready? Go. Even if you haven't done mixed numbers, I want you to try. I want you to think, okay? Go ahead. You solve that up there for me, okay? What's your thinking? While everybody else is working out, what's the first thing you want to do?
Add these two.
Okay. Add those two together. What do you get?
5, so I fit the 5 over here.
Okay. And then what are we going to do with our word denominators?
I'll grab that. We're going to keep it the same.
Yep. Sounds good to me. And now what do we want to do with our whole numbers?
We're still going to add them.
Are you done? Yes. So let's look at this. How many of us have the same answer of 5 and 5/7? So again, the first thing she did was she added the what? She added the numerators. We keep the denominator the same. And we add the whole numbers. Did anyone solve it different? Did anyone draw a picture or solve it differently? What did you do, JJ?
I got the whole numbers. I put them into the numerators so that they would be improper and easier to do. And then I took out the whole numbers.
So you went 7 times 3
21
plus,
3 equals 24.
okay. So you did 24 over 7 plus,
7 times 2 is 14 plus 2 is 16.
okay. And then what did you do next?
I got 24, added 16, and I got 30.
24. Well, 24 plus 6 is,
I mean, I got 40.
you got 40. There you go. 40 over.
7.
Then, JJ, how did you change that back into a mixed number?
I found out what times 7 gets close to 40. Then I took out that much and put it as the whole.
Okay. Can we also, I'm going to do a little division, okay? Because this is 40 divided by 7. So 7 goes into 40 about how many times, JJ? About 5. What? How many times? 5. Thank you. And what's 5 times 7?
35.
Okay. What's left over?
5.
And I always call it the fraction cycle. Real quick. And there we go. Same answer of 5 and 5/7. We have so much more to do with fractions, okay? But for now, we have to send it back to the studio, and we'll be back here in a little bit.
All right, thanks for that, Marylou, and thank you to the Raiders at Seibert Elementary. We do have phone tutors available until 5:30 this afternoon. We have Caleb, a 7th grade student from Grimway Academy, in studio with us, and it is time now for you to get back to work. Enough rest, right? All right. Order of operations, and we've got a problem up on the board for you to do. But before you do that, I would like you and Gustavo to talk a little bit about the order of operations and what you know, some vocabulary, and kind of how you go through this process.
Yeah. So some people may not know what order operations means, right? But they know it as PEMDAS, right?
Yes.
I think most people know PEMDAS. And so tell the audience, what does each word mean?
P is parentheses, M is exponents, or E is exponents, M is multiplication, D is division, A is addition, and S is subtraction.
Perfect. And why do we write them down in this order?
We write them down in that order because normally that's what you would do first. So first, if there's parentheses in the problem, you would solve parentheses and then go to exponents and so on. Except whenever you get to multiplication and division, then they're side by side. So it's whatever comes first in a problem. And same for addition and subtraction.
Excellent, excellent. So do you know any cool tricks of remembering this so that we can give the audience some
Yeah,
tips?
an easy one to remember. Please excuse my dear Aunt Sally.
Perfect. Yeah. Now, I wonder why they selected Sally and not Sue. Huh? I guess we're not excusing Aunt Sue then. Excellent. So we're going to use this in this problem up here. And let's go ahead and get started, and then we'll tell our audience and our viewers exactly how this is going to be implemented, right?
Okay.
Perfect.
Well, first, let's start off with these parentheses right here. We would do a -7 plus 7. Those would just cancel each other out. So now what we're stuck with is 0 divided by -9 to the power of 2 times 8 minus, in parentheses, -3 to the power of 2.
Perfect. And a lot of teachers are always telling their students, show your work, right? So today that's something that we're going to practice. That'll be one step, step 2, and then here so that if we were to submit our homework to our teacher, we would show our work, right? Perfect.
Yes. Okay. Next, what you would think to do is this right here. But there's really nothing here that we can do because it's just one number solidified. So we're going to move on to this set of parentheses. We're going to do 8 minus -3 to the power of 2. So here you would do 3 to the power of 2 since we're doing PEMDAS, and we would get 9 because 3 times 3 equals 9. So we have 9, or -9, 8 minus -9, or yeah. Okay. Then what we would do is.
So before you go on.
Actually.
Yeah, I was going to say you
Yes,
got that.
I
Okay.
just caught it, yes. So we did parentheses and now exponents, right?
Yes.
Exponents, if we do this the long way right here, it would mean 3 times -3, right? And
Yes.
so-
Oh wait, that equals a positive
Exactly.
actually.
And just as a side note, if for our viewers at home, if we had 3 to the power of 3, that just means 3 times 3 times 3, correct? Perfect.
Okay. Then we're gonna solve this. So this would equal -1. Okay. Now we're gonna write out our problem again. So we have 0 divided by -9 to the power of 2 times -1.
Perfect. And so here we're going to encounter the same step as there, correct?
Yes.
Perfect.
So we're going to do -9 times -9 to get a positive number. So now we have positive 81. And then we're going to write this out again. Times -1.
Perfect.
So now we look at PEMDAS again. We have two of the same, or not the same symbol. We have division and multiplication. In PEMDAS, technically the M comes first, but whenever we're looking at PEMDAS, these two are equivalent. They're right next to each other. So if you have a case like this, you're going to just go from left to right. So we're going to do 0 divided by 81 equals 0, and then 0 times -1 equals 0.
Perfect. Yes. And so we have our steps here. We could have step 5 and then 6. And yeah, that's I think that looks pretty good to me.
There you go. Nicely done. All right. Go ahead and erase that board if you guys would be so kind.
Yeah, I got it right here.
There you go. All right. Now, I said I wasn't going to give you another one of these, but you guys have plenty of time left, so I want you to do, this is one of the problems you did earlier. All right? So, -7x plus 8y is equal to 13. And we know the next equation is going to be 2y equals 12. So looking at that again, Caleb, is there some way you can start to make your life a little bit easier?
Yeah, what we can do first is we can do 12 divided by 2 to get 6. So 6 would be our multiplier here. So we would then know y equals 6. Now we can plug in 6 here. So now we're going to rewrite this equation. -7 plus 8, and then parentheses next to it, 6 equals 13.
Perfect. And if our viewers are wondering, where did we get this 6 from, right? Well, we got it from right here because we plug it in there, right?
Yes.
Excellent.
And next to your -7, make sure you put an x in there also.
Yes.
So it's
-7x.
-7x.
Oh, yes.
Perfect.
Next up, we're going to do multiplication because multiplication comes before addition. So now we're going to get the answer from 8 times 6, which equals 48. And then we're going to rewrite the equation again. 7x plus 48 equals 13. Okay, the next step of this equation is we're going to cancel out 48. So we're going to do minus 48 right here to get 0. Then we're going to do the same thing over here. So minus 48. We're going to be left with a negative number now. So what we're going to do is we can't really, we'll do an easier way. We'll do 48 minus 13. So you get 5 and 3. Now this right here is going to turn into a negative number because this number takes over. So it would be -35. Good. So now we're going to rewrite our equation again. -7x equals -35.
Perfect.
Okay. Now we have to solve for x. So easy way to do this is we do -35 divided by -7 to get our answer of -5. No, positive 5.
Yeah. So we want to show that we divided by that -7, right? By doing one of these guys, and then that cancels out, and we're left with x equals -35 divided by -7, which is
5.
perfect.
Equals 5.
Excellent. And so now we know that y equals 6 and x equals 5. Correct?
And what I'd like you to do is maybe write that in an ordered pair. So inside parentheses, put your x value first, put a comma, and then put your y value, and then close parentheses. So that way you've got the answer written as an ordered pair. That makes sense to you? If not, Gustavo
Have
can
you
kind
seen
of
it
show you.
how sometimes books will show it like this?
Yes.
And so let's just say that in my book I had x is 5 and then y is 20. For your answers, how would that look?
All right. So we have x and y. And then we have 5 and 6.
Yep.
I don't know what that is.
That's a y.
Yep. I don't know why I wrote a 7, but.
Perfect.
There you go. Nicely done, guys. Congratulations on that great work. And we're also going to award you with another meal, this one courtesy of our friends at Chick-fil-A. So nicely done on that. Hey, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We do have another opportunity. We're going to head back out to Marylou and the students at Seibert Elementary.
We are back at Seibert Elementary School, ACES After School program, and I'm with a lot of fantastic 4th graders. We have been working on what today, everybody? Fractions. So we have decomposed fractions, we have added like terms, but now we're kicking it up, and we're going to do a little bit of multiplying fractions, and we're going to go back to adding and subtracting fractions together. So all of it together. So the first thing we want is, we talked a little bit about PEMDAS, okay, order of things, and we need this for what's coming. But first off, let's quickly do a little multiplying of fractions before we jump into this. So if I had 3/4 multiplied by 1/5, what am I doing first? What am I doing first?
First, you have to add the first you have to multiply the numerator.
Very good. I'm just multiplying straight across, right? This is multiplying fractions is just like multiplying numbers. It's saying I have 3/4 groups times 1/5, right? So we're multiplying straight across. My answer is 3 what? What's 4 times 5, everybody?
20.
20. I love multiplying fractions because it's pretty simple, isn't it? So we know how to multiply fractions, right?
Yeah.
Okay. So now let's talk about PEMDAS real quick. What if I had this? So write that on your board. 8 divided by 6 times 4. Okay? Think about our PEMDAS. What's the very first thing of PEMDAS? What's that letter? What is it, everybody? The what? And the P means what?
Parentheses.
So the first thing we want to do is solve what is in the parentheses. What's inside my parentheses?
6 times 4.
What's 6 times 4, everybody?
24.
Okay. Ooh, I think I wrote that backwards. I did. Let's do this. I wrote that backwards. I'm going to rewrite this real quick. Let's do it that way. Yes? This will make more sense. So we have 24, and now we have to bring down our divided by 8. So what's 24 divided by 8? What is it? Just show me with your fingers. What's 24 divided by 8? Show me with your fingers. That group's got it going on over there. Those gentlemen, thank you. And everybody in front of me, we all know the answer is? 3. So what do you think of PEMDAS? Yeah? Yeah. Okay, so now I promised you guys that we were going to mix fractions with multiplying and adding and subtracting, yes?
Yes. Yes.
Okay. Here we go. You ready? You guys can do this. So, I have, here you go. Write that down. 4/5 times 4/7 minus 1/7. Working with your groups, I want you to start talking it out how you guys are going to solve this. Go.
First, at the top, we're just going to do the subtraction problem.
So what do you got? What's your first thing? Where do you want to go first?
The parentheses.
Ah.
So we're going to primarily do the subtraction thing, then do the multiplication with the subtraction thing.
Well, let's see. See if it works. What do we get first? What did you get? Yeah, I see you have an answer here.
3/7.
Okay, so what are you going to do now with that equation?
I'm gonna times it with 4/5.
Okay. So what do you think you're going to get there?
Ooh, I know what you get. You get 12/35.
Okay, well, let's see. Ladies over here, tell me what you did.
So first we subtracted these, which we got 3/7. Then we multiplied it with 4/5, and we got 12/35.
Okay, all right. What about gentlemen over here? How are we doing over here? Where are you going to start first? Looking at our PEMDAS, where do you want to start first?
The parentheses.
Okay, so what do you think your answer is there? What's the difference of 4/7 minus 1/7?
3/7.
Okay, so where are we going to write the 3/7? We going to do it underneath it? So we still have this left. What are we going to do with that?
Multiply it by this.
Okay, try it. Bring it down. All right, ladies, how we doing?
Pretty good.
Okay, don't forget your parentheses. Put your parentheses around that, okay? Think about what we're going to solve first. And how we doing over here? Okay, explain what you did.
Okay, so the first thing we did was 4 minus 1, which we got 3, and then the numerator is the same. So when we did that, we got 3/7, and then we times 4/5,
and 4 times 3 makes 12, and 5 times 7 makes 35. So we got 12, 35.
Awesome. All right, class. I'm walking around and pretty much, let me hear the answer. What is it again? 12. So you could go back and let your teachers know that you did a little bit of 5th grade math today. Okay. And how you're ready to go with fractions. And it's been a lot of fun today. Thank you. You guys have been absolutely wonderful. And you are spot on with fractions. And that is it from Seibert Elementary. Back to you in the studio.
All right, thanks for that, Marylou. And once again, thank you to all of the students at Seibert Elementary, as well as the staff for allowing me to do the math, to come on out and visit them in their classroom. We do have phone tutors available until 5:30 this afternoon, but we have Caleb in studio. You've done well with the order of operations. We just saw how the kids at Seibert were working on it. So I have one final problem for you, all right? Over to the board, young man. Here we go. We have 10 plus 4 times 2 minus 4.
Okay.
Evaluate that.
First, I'm going to want to apply a PEMDAS to this. So I'm going to do 4 times 2, which equals 8. And then I'm going to rewrite my problem. 10 plus 8 minus 4. Now, addition and subtraction are right next to each other in PEMDAS. So in this case, we're just going to go from left to right. 10 plus 8 equals 18 minus 4 equals 14.
Perfect. That is really, really great. So there's a couple of ways that people could possibly get this wrong if they don't follow PEMDAS, correct? Yes. So let's try it. Plus 4 times 2 minus 4. So let's just say if people didn't know about PEMDAS and we just go 10 plus 4 and then times 2 and then minus 4, what would we get? We would definitely get it wrong, correct?
Right. We would get this wrong. But if they were to do it that way, here they would get 14 times 2 minus 4, 28 minus 4 equals 24.
Yeah, and so that's definitely
wrong.
And so this is using, please excuse my dear Aunt Sally, and that side, it's a happy face, because that's the way we want all of our viewers to do it, correct?
Yes.
Perfect.
There you go. Nicely done, guys. Come on back over here. I'm glad you put a big X over that, because sometimes people are watching and they're not listening. Mm-hmm. They're just kind of flipping through and they see it, but they don't listen to what's going on. So I'm glad you put the big X on that so that you know that that is the incorrect one right there. We do have phone tutors available until 5:30 this afternoon. And this is your big day on live TV. Is there anybody you would like to send out a special hello to?
Yeah, I'd like to thank my grandma who's watching the show live right now, and my mom who approached me with this opportunity.
Oh, there you go. And we are certainly appreciative of you being able to take some time to come on in and help us with Do the Math. Did you have fun today?
Yes, I did.
I know, because a lot of students get nervous when they come on. It's like, oh, live TV, I got to do math and stuff like that. They get really nervous. And also a big thanks to Gustavo from KERN Tutoring. And once again, Gustavo can help you out if you need a little bit of help with some higher level math, some reading, other subjects and things like that. So we do appreciate Gustavo coming in also this afternoon. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-BUENA VISTA Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.